Wonderful, and that seems like a confirmation to me. Okay, Markus, I'll play, and then I think in 35 minutes we'll have Q&A.
Yes.
Evolution of Functional UI Paradigms by Mike Sperber and myself, Markus Schlegel. Our paper consists of two parts. In the first part, which is mostly Mike's work, we discuss the evolution of UI toolkits from the 1990s through the 2010s. And in the second part, we identify an inherent difficulty in working with UIs that is generally not talked about much. We then discuss a new approach to work with this difficulty. The answers of UI toolkits in general, the object-oriented model view controller pattern. MEC is built on the idea of separating concerns of the domain or business logic as the model from concerns of the user interface that is the view. Controller acts as a mediator between these two program parts. In our paper, we identified three main challenges that arise from this pattern. So the update, modularity, and circularity challenges. The update challenge arises because in MEC there's two ways how something appears on the screen. Initially upon UI construction and then incrementally every subsequent update. This may lead to duplicate and therefore strongly coupled logic. For the modularity of challenge, we ask, can we properly separate concerns between model and view? That's the result that will for the MEC pattern, and also between different parts of the model or different parts of the view. And then there's the circularity challenge. So naively implemented changes to the model trigger calls to update the view, but that in turn might spill over into changes to the model, and so we have a circular dependency there. And then as a bonus challenge, we have the event loop, which is a constraint imposed on the frameworks by the platforms, such as the browser runtime, that may lead to the so-called callback hell. Now, there are UI toolkits for functional programming languages that just wrap imperative toolkits like GTK or the web browser's document object model. But right from the start, there were also UI toolkits that tried a more functional approach, like Xene, Fudges, Fruit, and Haggis. However, all of them inherit at least one of the three MEC challenges on the previous slide. And in particular, most inherit the update problem. The Racket Universe Teach Pack specifically addresses the update problem by not making a distinction between initial UI construction and UI update at all, and instead re-rendering the entire UI from scratch on every tick of a logical clock. So here we have the, so to speak, the framework of the Racket Universe Teach Pack. So you don't call these functions, but you have to implement them. You want to write a Racket GUI program, you could say, or a game. So we have an on draw, which takes some state and returns an image, on tick, which moves on the world state. Then you have on key and on mouse, which react to these particular key events or mouse events and update the state and response. And a bit later, there is Elm. Also, you might know this pattern by the name of the Elm architecture, or sometimes it's referred to as the model update, which is quite similar to what the Racket Teach Pack does. So in the Elm architecture, we have a view function which takes a model, so description of the state, the domain logic, and turns that into HTML. Then you have an update function which takes a message, and these messages come from view and your current model, and it updates the model. And then there's React, which came about at the same time, basically, as the original version of Elm. Facebook released their UI toolkit, which turned out also based on a variation of the model update paradigm. So both Elm and React leave solving this modularity challenge to the developers. Let's go back here. Also here, there's no notion of a UI component. There's just these four functions or these two functions. And how you then decompose them further is that. Sadly, the communities, so the React or Elm communities, they couldn't really come up with satisfying solutions to this modularity problem or modularity challenge. So, for example, even though React, other than Elm, has the notion of UI components built from smaller UI components, the React community adopted the Elm architecture in the form of a library called Redux, for example. And thus they introduced strong coupling between these components, rendering the idea of individual UI components less useful. And that led to the creation of React. So in 2014, Mike, my co-author, set out to solve the modularity challenge. The closure script library built on top of React called React. And our paper describes in detail how that works. In this talk, I'll not show you React though. Instead, I want to introduce you to another challenge and then show you an update on React code. I can see in detail. Few slides. Because even though we were satisfied with React as a solution to the update, modularity, and circularity challenges, and we used that library extensively over many years in our client projects, we felt that there's still something amiss. And one symptom of this feeling was that so me personally, I very rarely write automated tests for my UI code. And that's partly due to me being lazy, but I also write few UI tests because I think most UI programs come with vague semantics and are therefore not even testable. So I've tried to illustrate that with the simplest possible example. So here we have a pure function that is something like the view in the model view update. So we want to display some temperature values. So this function takes in a temperature value, in this case it's just an integer, and then displays a GUI for that. So there's not even any interactivity going on here. It's just we statically render a div with some styling, and then we bring that temperature value into string form and display that as well. And there's an additional requirement that these temperature values fall into one of two classes. There are normal temperatures, which are fine, they just display on screen as text. And then there's too hot temperatures. So here we have this too hot predicate. And in that case, the requirement is that we want to emphasize this temperature display. Here we decide to do that by giving the div a red background. And now this is a pure function, which means, which should mean we can easily write tests for that. So we do that. Here we have a test for one case where we did want to display the temperature 22, and then we expect that to be a div with the string 22 inside. And then there's the other case where we pass in 183. We expect 183 to be displayed, but then we also expect this background to be red, right? This is a too much of a temperature. Now these tests work, and they can be automatically checked, right? But still they're very bad tests because they test an aspect of the implementation. Because the requirement in itself, so the specification, you can say, just mentioned we want to emphasize too hot temperatures, but here we decided to implement emphasis as the red background, and the test also refers to the red background. So now here we don't have any chance to later make it different, but equally valid decision of maybe emphasizing by giving it a red border or displaying a little exclamation mark next to the temperature. These would all, I think, be perfectly valid solutions for the emphasis requirement, but the tests would go red because they are too specifically tailored to an implementation. And these kinds of things happen all the time in genuine UI code, I think. Or at least that's my experience. So there's this paper from 1980, which I think nicely illustrates what is going on here. This article describes three classes of programs: S programs, P programs, and E programs. And it defines S programs as those programs whose function is formally defined by and derivable from a specification. And then there's P programs in the middle, as a middle ground, and on the opposite end of that spectrum, there are E programs, where it says the third class E programs are inherently the more change prone. They are programs that mechanize a human or societal activity. And I think that's exactly what's happening here. So if you take another look at our little example, I think we can easily identify an S part, so an S program part here, which is this toolkit function. I think it's really easy to specify that formally, right? And you can check it with the test or even. But then there's this red background, which is the implementation of the notion of emphasis. And the notion of emphasis is a human or societal thing, right? It's very hard to formalize, I think. So you would have to check or you would have to come up with a formal specification that both captures red borders, red backgrounds, and exclamation marks, and so on, which are all valid implementations. I think that's really hard to do. And it also depends on what is surrounding the element, right? So if you want to emphasize this small little temperature display, but there's a lot of other widgets going on the screen at the same time, then I think maybe just the red background might not be enough. You have to do more. And also these notions of emphasis, they change over time. So many years ago, when people were not that familiar with graphical user interfaces yet, the general public, you would maybe have to do different things than today, where people are in front of their computers all the time. Right, so these things change, they're hard to specify. And to sketch out where I want to go with this graphically, here's a big oval that stands for our entire UI application. And I think in general, these UI applications are E-programs, so they're hard to specify things in their entirety. Now, it doesn't mean that all is lost, right? We deal with this situation in the same way we deal with most architectural problems, and that is by modularization. So that's what MVC tries to do, for example. So we split the application into a view and controller part. They are usually strongly coupled, so that's the inner red circle oval. And that's an E part, and therefore has to be tested manually. I think just in general in most cases. And manual tests are costly. We want to not have. And then there's the model part, the green part, which at least has a good chance of being an S part where we can have a precise specification. And they're therefore better suited to automated unit tests. Now, the red part is still quite large, right? And our goal is now to make this red part even smaller. That's where I suppose we take to another pattern from the object-oriented world called model view model, carry that over into our functional world. So here we push the E program part into just the view, and we design the so-called view model as an S program. The view model is a description of what's happening in the user interface without talking about concrete visual representations. And we'll see that in a few minutes with a concrete example. Now, to implement this pattern, we need library support. We need a UI toolkit that allows us to write as little genuine UI code as possible and make the glue code between the view and the view model as small as possible, and in the best case, trivial code. That's something that React, the original React, didn't quite allow us as much as we would like it to work. So that's where React C comes into play, which I'll now introduce in more detail. Okay, so here we are in a closure script environment where on the left I write some code, and on the right we see the result of that in the browser window. So React C is a library for browser UIs, and React C is sort of programming model in that model, combination model. So you have some things that we call items, that's a unit of composition, and items can have a visual representation, and they deal with state, or they have state, which means they have implicit and implicit value associated with them, which they can read from and write to and or update. Here we see already the simplest possible item, which is a primitive, and that's nil. So that displays on screen as nothing, as you can see on the right, and it also doesn't do anything with state yet. The next step are strings, so like this hello world string. That has a visual representation, and that's just itself, where it just displays the string on the screen. And that doesn't do anything with the state yet as well. Now, one step further is to have there's a namespace DOM here, which comes with all the DOM elements, such as div, and that takes as first argument an attributes map, which we can, for example, use to give this the red background. This is an item combinator, which takes in an item, right, such as this string, and then wraps that in this corresponding div element. Now, this div, or most of the token elements, they also allow you to combine multiple items into one. So if we have two items, I and J, and they're both on strings, then we can display them next to each other with this div as well. So here we display hello world next to each other. But still, nothing about state yet. So now we'll look at a simple button. And that button also takes a special attribute map as its first argument. That can have a special attribute, something like onClick, which takes an event handler function as its argument. And these event handler functions are pure functions going from state to state. So here is that's the point where you can update state. So here we give this lambda with the argument is called state, and we want to build an increment button. So we want to update the state by adding +1 to it. And the label of this button should be just increment. So now we have a button, it says increment, and it also works. I can click on it, and I have to tell you that it works, but you don't see it yet. And so we use state and we update it, but we don't display it yet. That's where another item combinator comes into play, which is called dynamic, which takes a function, and that function in turn takes the current state value and returns an item. So we can do something like this, where we take the state and then return an item. So we already have an item in the form of this button. But now this argument can be used, for example, to display as the label here. So we put this integer here with state, which is called state, into a string. We save that, we see, okay, we already clicked the button 9 times apparently. We do it again, we see that it is indeed incrementing a value. Right, now, for a slightly more elaborate example, let's quickly get rid of all that. Or not, let's put this into a separate. Let's give this a name basically. So this is our increment button. That's done basically. So this is we'll hopefully not have to touch that anymore. But now we want to have a large application that deals with tuples, so a set of 2 values, and the 2 values are integers, and we want to have 2 separate increment buttons for the 2 components of that tuple. So first of all, I'll have a button that resets this this tuple. So again, we write a button with an onClick handler that doesn't care for its argument, always returns 0, 0. And that is the reset button. So we save that, we should see that, right? If we click that, nothing happens because we don't display it yet. That's what we'll do next, but not by using, by going from start again, but reusing the increment button. But if I write increment button here now, I think it displays this tuple. But if I click it, I think it will just crash or whatever, because incrementing a tuple doesn't make any sense. So we want to have the increment button. So the increment button is fine, but it's in the wrong context at this point. We want to have that be responsible for just a part of the current state. And that's where another bread and butter combinator comes into play, which is focus. Because we notice that in, say, 90% of the cases, the relationship between a parent component and a child UI component is that of a lens. So where we have a get which takes from a large value a smaller part, and a put back function which puts in a new small part into a larger structure. And that's what focus works with. So focus takes as its first argument a lens, where we already included a lens library for that. So there's a lens first, or the first part of the tuple. And then focus as a second argument, it takes an item that works on the smaller part. And if I say that, or if I copy that for the second part and give that a second lens, say that, we should see two buttons or three buttons with the reset button, and they both work on the individual parts of the tuple. You can verify that by having the state also be printed below. It's a raw form, right? So here we see the right button works on the right component, left button works on the left component. And resetting means just resetting both to 0. And now the React C library comes with a few more combinators that also work with concepts like effects and actions and subscriptions and messages. But in most day-to-day work, these few combinators that we saw, dog dynamic, all of the DOM elements, and focus, they are enough for 80 or 90% of your UI application. And I'll now illustrate that with a larger example, the phone book. So as a starting off point for our little phone book example, I already defined a text field component, which is something a bit like the button, right? So with dynamic, we get to the current text, and then we display an input field where the value of that input field is the current text, and on change, that is one of the handlers like on click. We want to update, and what we want to do is take this event, which is an option second parameter to this event handler callback, and from that we can get to the target and then to the value. So this is just using the DOM API basically, and we set that value as the new state. And here I just display this input field, and also I have this little debugging device here which just prints out the current state in its raw string form. And then you can see the isolate state, which is another combinator that I didn't go into before because it's mostly used as here it's mostly just used in a demo where I will set the state to a completely new context. So this severs the state of everything that comes below from everything that comes above this top level, which is in this case. And here we can write state values that we want to work with for this demo purpose. So here we say we want to work with this hello state. So refresh this page, we start with a hello string and a text field. And now we can type here and see the state change in our little debugging view here. Okay, so now this is our starting off point, but we want to now make a bit more structured application that deals with phone book entries. So our model, we first of all define our model, completely devoid of any UI concerns. We can have a record, so we have an entry. So this is our main model, and then we have a little constructor here, say for an empty entry. That's our simple model. And now we want to build a UI for that entry, also for a single entry now, just with the help of the text field. We do that by introducing another item. We call this entry item because entry. We could also say here model is entry as a comment. And an entry item displays just div with these two parts, phone book and name. So there's one part where we have a name label, which is just a string, main string embedded items. And then we want to focus on the first part of our record, and the record accessors are already valid lenses. So remember, focus takes a lens. So this is called entry name, right above here. And the entry name is a string, and that can be dealt with via our text field. Let me do the same for the telephone number. If I save that, it will not work because I have a string here, so I'll have to start with something like the empty entry state. Right, so this is the raw string display of our entry, and here we have the GUI file. So name, now it's an empty string, but if I type something here, my name, my telephone number, then the entry is actually manipulated. Now, phone book is not just one entry, but a series of entries. And we'll just say that we don't introduce another direction here. We just say sequence or a vector in the closed case of entries is now our phone book. And that means we'll have to have an item dealing with these sequences of entries. So let's call this the phone book item. And here we do something slightly different. So here we first need to get hold of the state, which we call entries. And now we have this. So entries can be 1, 2, 3, or an arbitrary amount of entries. So now we have to apply our DOM function, which is also variadic, to an appropriate amount of items. So let's do that. So we apply this DOM div combinator to now a sequence of items. So, and the sequence of items, of course, is derived from the sequence of entries. So we can map over the entries here, or rather, what we do is we map over the indices like that. So here we get an index. And now we want to do something like this, right? So entry item here. But now the entry item has to be responsible for just one part of this entire sequence at that specific index. And that's also possible by using focus with the appropriate lens. And that lens here in our case is called at index. Okay, now we can see that our state is now a sequence of these two empty entries. Okay, here to here and the other from here to there. And already our GUI is displaying two entry items on top of each other. So if we say my phone number is this, my phone number is something like this, then that manipulates our phone book appropriately. Now, this little dance of calling dynamic and then apply to some div and then using an at index lens, mapping over the entries with range count and so on, that's quite a common pattern that appears quite often. So you can imagine whenever you have as your state a list of something or a sequence of something, something like that has to happen, probably. So we can just extract that into a combinator of our own design. So let's quickly just copy that over, make this into a function, and we call that map item. So, and then we do basically the same thing here everywhere. Let's call this the axis, and we apply a div to that. We go over the axis, and then call that at index. And then entry item is replaced by our parameter child item. And then our phone book item, of course, can again make this more concrete by saying that's just map item of entry item. Now, our phone book is not quite complete, right? So we started with 2 entries and we can manipulate these 2 entries, but we cannot yet add new entries. So that's what we'll do next. So we define a phone book item. And that just calls, or that just wraps phone book item with another little button And then what we want to do when someone clicks this add button here? Well, of course, we want to add an entry to the phone book, and in this case, we just inline here. So we say concat our phone book, which is a series of entries with a new list just holding the empty entry. So let's use it also. Button item. Here's a button, and if we click that, we see our state changes, and our GUI already also reflects that. Right? So this is something new here. Now, what I want to really do is introduce you to this view model pattern, the functional view model pattern. And which sort of view model is a model in between your view and your actual domain model. So the view model captures aspects of the UI, but not talking about concrete representations or concrete visual representations yet, but have that be a bit more abstract and still therefore be better testable also. And I will introduce that by introducing another requirement here. So adding new items is fine, but if there's lots of entries, and maybe you have a situation like this, right, where you have some empty entries already, and then you added, click the add new button, you don't really know what's happening on screen. It's very confusing. Our new requirement is whenever we hit the add new button, we want to highlight, we want to emphasize that newly created item, right? And emphasis, already, I talked about it before. We can just capture the notion of emphasis as a black box for now. So we say is an item combinator emphasize, takes in an item. And then, well, for now, our implementation is just that we have this red border, right? So, and from now on, so this is our little, small little view part that cannot, I think, be tested automatically because the notion of emphasis is very vague. A human has to look at that and decide if that's emphasis enough or if there has to be something different happening. So I think this is not testable automatically, but it's also very little code, and I try to isolate that and have it decoupled from all the rest as much as possible. So what I'll introduce now is the functional view model. And so we have our model, so our domain model up here, that can stay as it is. But now I want to also write a view model. And that view model now has to talk about which entries do we want to have emphasized. It doesn't talk about how it's emphasized, but just which ones, right? So here we have another record. Let's call this entry VM for view model. And that has two fields, the entry VM entry, so that's the actual domain entry here. And then an entry VM emphasized flag, which is just a simple build. And we can again define an empty phone book. And as a little helper function, I will define a de-emphasize function. So this is just a pure function on the view model, takes in an entry and returns an entry where the emphasized flag is set to false. And now I will also want to fulfill the requirement that, well, when a user clicks on the add new button, there's one new element or one new entry appearing on screen, and that one new entry should be emphasized. So none of the others. So if one of the others was emphasized before, they should all be deselected, so to speak, or de-emphasized, and just the new one should be emphasized. And that's something I can easily just capture in my view model. That's nothing like that. That's not a view concern per se. It's a view model concern. And so there are many ways I could have this constraint be implemented. In this case, I just opt for a smart constructor. So there's an add new entry smart constructor. So it takes some entries or a phone book, you can also call that. And it constructs a new phone book, which has a new entry. And here we do de-emphasize all the old entries and then add a new emphasized entry to that, right? And now, so this concludes our little view model. And these are all things that can be automatically tested. There are good candidates to do that. Okay, and now that we have this, we still need to write a GUI for that. But that should now be trivial, I think. So we already wrote this little emphasize helper combinator down here. We also need now, let's put it somewhere here. So now we need a new entry item for our entry view model. And we do that by get to the current state, which is an entry view model. And so what we can do is just to reuse what we wrote before by focusing on the entry. And we already have a UI, an item for entries, which is this entry item, right? So that would work. But of course, we want to also now incorporate this emphasize flag, which I'll just do by seeing if that is set to true or false. And then depending on that, we either wrap this element in the emphasize combinator or the combinator of that, just to check if everything is going according to plan. Yes, so this displays our what we wrote before, the entry item, and depending on this flag here, it's either emphasized or not. So now we also need a phone book item, which again we can just map item with our entry item 2. But we're still missing our add new button. So let's quickly say there's also a phone book with add button item number 2. And again, this is very formulaic. Just reuse the phone book item 2. And then below that we have this button, which on click adds a new entry. We can directly refer to that function as is. We now have that button. Can write something. We immediately see, okay, this is the blue bordered entry is probably the one we just added. Right? And if you click it again, that focus switches to the newly created item. Again. So to quickly recap what we did here. So first of all, we started with a few primitives such as the text field. We defined our simple model up here, right? And we could already immediately write some UI components for this entry and phone book model. But now that we also have some requirements that require us to talk about complicated, intricate UI concerns. That's the point where we introduce a view model to decouple these concerns, or to decouple the S parts of the program from the E part, or make the E parts as small as possible. So we introduced the view model, which now doesn't talk about these vague notions, but it talks about them, but in a way that just pushes the actual vagueness out of that view model. And so that is amenable to tests. And that's what I actually write tests for in my applications. And then the next step is to write GUIs for that view model. But I hope I could give you a good enough insight into that. And what I wanted to illustrate is that the code then is actually quite simple and very trivial. So all of these items here, they just follow the grain of the view model. And there's really nothing going on here. So it is so the nicest piece of code, I think, is something like this add new button, which is just, well, it's a button, and what is its functionality, but something that we already defined in terms of the view model down here. And now I think a test that checks for the functionality of this add new button is now superfluous. Well, there's really nothing that you have to test here, I think, which is not yet tested in the test that corresponds to add new entry itself, so the view model part. So that concludes my little talk. Thank you all for listening, and now there's a little bit of time left for questions.
Okay. Great, I'll put Markus in. So sure. Oh yes, that is what it has to be. There we go. Can you hear us, Markus?
Yes.
Perfect.
Hello.
Okay, we have some. I think we have 2 minutes for questions, unless you want to stay later. And then
Sorry.
let's do another round of applause so that you can hear us again. Anyone have questions? Oh, yes.
Well, first, thanks for the nice presentation. I
You hear
well,
that, Markus?
Yes.
okay. While I couldn't quite follow the development of the code, in the last part, it looked like almost like rewriting the code that had been written previously, rather than directly extending it. So that seems not particularly modular there. I was wondering if that was a presentation effect because you were building up, or would you have, in a real development, would you have already set things up so that you could more easily add code without replacing, or is it a feature of the system in its present form?
I think it's a bit of both. So so I did reuse the entry item that I wrote for the without the view model code. I did reuse that, but I didn't reuse the mapping over the list, right? So I prepared the demo in that I had this map item combinator, extracted that before because I knew that later I would have to use that to make the demo go faster. But I think that's just normal functional programming there going on. So what recursive allows you to do is to find these looser coupled combinators like map item or like the entry item that you can reuse later, but it doesn't like it's no guarantee, right? So if you write something and then your view model or your requirements change and you introduce this view model in direction and stuff is just organized differently than what you had before, then there's really nothing you can do about that. Maybe you find some small things that you can reuse, but there's no guarantee, basically. So it's just, so what you saw was just pure functions composed together. So that's the issue that you have everywhere else as well, I think.
Any other questions?